Andrew Selke here with Richcom at the Beijing Audio Show. And I just wanted to introduce you to Varèse, which is our new flagship product announced a couple of years ago, started shipping towards the end of 2024. And this is the most ambitious streaming DAC that we've ever released. And I'll just take you on a bit of a guided tour. So this is a 6-box system. We have a SACD transport here. We have a core, which provides the input switching and also the digital processing, the digital pre-processing of the incoming digital signals. We have dual mono DACs for the first time. We've split the conversion process into 2 separate chassis. And then down on the bottom layer, we have the master clock, as is common, has been a common thread through our last few generations of products. The UI combines all of the user interface elements and controls for the entire system into one touchscreen unit. So I think the big change, the big evolution which Varèse brought was the movement from stereo to dual mono DACs. Our engineering team were looking at how they could push the envelope on performance, extract more performance from the Ring DAC architecture, which is our patented discrete conversion architecture. And they became intrigued with the possibilities of splitting the conversion process into dual mono, which has a variety of advantages. Enables infinite crosstalk, just for starters. It also reduces the interdependency through the power supply. Each DAC is fed with its own dedicated power supply. It also gave us the freedom to exploit the real estate available to us in the chassis in a new way, and the engineering team came up with a new evolution of the Ring DAC, which is a differential Ring DAC, where we're using twice the number of current sources compared to the traditional Ring DAC, half of them in phase, half of them out of phase, which gives us some of the benefits of common mode rejection that you would see in a balanced circuit. So dual mono Ring DACs, this introduced a major challenge, however, which is when you're converting, in the simplest case, 44,100 samples every second, how do you ensure that each DAC is converting exactly the same sample at exactly the same point in time? So we needed a way to synchronize the conversion process with very, very high precision. And the team came up with a novel solution, which nobody had cracked this challenge before, but they cracked it with something that we've patented as a protocol called Tomix. And what that does is it basically takes the trailing edge of a clock signal, which is a square wave, where the leading edge is used as the timing reference for conversion, and the trailing edge is just a recovery phase to bring the clock line low again. It uses this trailing edge to encode a code. So basically we modulate the trailing edge, we bring it forward, represents a binary 0, push it out and represents a binary 1, and then we devised a way to use this code to embed timestamps effectively into the clock signal, so that the DACs could determine exactly which sample they were converting when it had left the common core, and ensure that they remained in synchronization throughout the conversion process. So as I say, our statement product, just to point out that the transport and the master clock are optional. The core system, or the main system, consists of the core, the dual mono DACs, and the user interface component. So thanks very much.